Hello all, welcome to the project Bangalore Housing Price Prediction. So now the main aim of this project is to predict the correct housing prices for a given locality in Bangalore using machine learning techniques and automated machine learning. So now let's proceed. So what is the motivation? So this is a very common thing which you come across in your neighborhood. Like what are the things that a potential home buyer consider for before purchasing a house, right? What do you consider before purchasing a house? The location, size of the property, vicinity to offices, schools, parks, restaurants. But there is one major factor which you see the very first, that is the price which fits, if it fits in your budget, no matter how big, how good the house is. If the house does not fit in your budget, you cannot afford it. If you cannot afford it, if the price is not good, you will not buy it. So basically this is the project about it. Basically we'll create a machine learning app which can predict the prices of a houses in an area. So now what we will do, we'll be creating a machine learning model which will help us in predicting the prices of the houses in a locality. In Bangalore, we have taken the city Bangalore as we have data of a Bangalore city on importing some of the attributes. So here we are provided with a data set which is containing information about the housing and their prices in different localities. Okay. So we'll be using the automated machine learning and different machine learning techniques for this. So moving on for the automated machine learning. So automated machine learning enables developers with limited machine learning expertise to train high quality models specific to their business needs. Basically, automated machine learning automizes the model development part. That's all. So now we'll be using the automated auto sklearn library, that is a free machine learning library where for which you provides user from algorithm selection and hyperparameter tuning. All of the things is done automatically in auto sklearn. There are obviously two types, classification and regression, based on different problems. So this is basically an auto sklearn library. You have heard or you know about the sklearn library, right? All the different sklearn libraries present in it, the regression, classification, all the libraries which are present. Okay, so basically this is done, the all of these things is done automatically with the help of auto sklearn. We'll be seeing how we can do the same with the help of with this in our next sections in our Google Colab environment notebook sections. So we'll be seeing how we will be doing. So the timeline of the project will be like this. First we'll be importing all of our data, then we'll be doing the data analysis. Okay, we'll be visualizing our data, finding out relations, then we'll be doing feature engineering, or basically let's say data pre-processing techniques. We'll be using different one-hot encoding, handling missing values in or outliers, adding features, removing features, all of these things, basically making our data ready for our model building. Then we'll be using different machine learning techniques to build our model. That is the regression problem we have. So we'll be using different regression machine learning models. Then we'll be shifting to automated machine learning. I'll be seeing how we can do automate the model development part in this video. So this will be a pretty interesting project. Let's begin. Hello, welcome to our notebook section of this project, predicting house prices in Bangalore using machine learning and auto sklearn library. So in the previous introduction section, I have already told you the context, okay, why we are doing this project, because obviously the major factor while we buy a house is the price. If the price is not affordable, we'll not buy out, no matter how good or how good the locality of the house is or how good the house is. So this is a pretty interesting problem of predicting the price of a locality, so that you can select your correct place where you have to buy the house before even going there. So data set is downloaded from Kaggle. The basic data set is given here for the basic Bangalore house predictions. We'll be using machine learning and automated machine learning for this project, auto sklearn. The timeline will be like this. We'll be doing data analysis, feature engineering, data pre-processing, model building using ML, using auto sklearn. So the very first thing we have to do is we have to import important libraries, right? So we have importing pandas, PD, SPD, NumPy as NP. Matplotlib basically a visualization, NumPy for pre-processing, and then first we'll import our data. So now to import our data, what you have to do, you have to first import your CSV file in your Google Colab or Google Drive. For which you have to import your data into Google Drive. Then you have to mount your drive. You have to mount your drive. You can simply mount your drive using a simple command, or just click this button. Click this button, it will create you this account with this link. When you execute it, it will provide you a link. You just have to authorize Google Colab to access your account. Select an account, press enter or press sign in, and it will give you authorization link. You have to copy this link, and basically this is the authorization code. Copy this code and press here, press enter. Now it's that easy. You have to just import your file in your Google Drive, then you have to mount your drive, as it is saying mounted at content drive. So when you'll see the drive is mounted, then all the different things are there, and you have to just select your CSV file, that is the Bangalore house pricing. You just have to copy it, copy the path, and copy the path and paste it here. I've already done it. Paste it here and read it using pandas. It is as simple as that. So this is done, already done. All the different things are done. Df.shape is already done. As you can see, there are 1 lakh, 1 lakh 33,000 rows. It means that 1 lakh 33,000 rows houses data is present. So this is basically the thing. And if you now in the next section we'll be doing some data analysis part. This was the introduction of how to import your data and how to do all of these things. So in the next section we'll be doing all the other data analysis and data pre-processing part. Hello all, welcome to our next section of the project. In this section, we'll be doing some data analysis or data pre-processing part, visualizing our data, seeing our data, doing different things. So now let's first have a look at our data. So this is our data. It has different attributes like area type. What is the area? It is a built-up area, plot area, then availability, ready to move, or when it is available, the location, the size, society, and total square feet of that house, bathroom, how many bathrooms, if there is a how many balconies, what is the price. If you'll see the shape, what is the total shape of our data. So as you can see, this is a pretty large data set, around 1 lakh 33 well 13,320 rows and 9 columns. So when now let us see that how many different area types are there. Okay, so as you can see, this is super built up area, 8,000 built up area, plot area, carpet area. So okay, these are different area types. So now we are dropping some of the variables which are not required. Okay, we are dropping area type, society, balcony, and availability. We don't want availability to be price located. We'll be dropping society. We don't want that. Okay, we don't want what society is there. We don't want balconies. Okay, we don't want what is the area type. That does not have such impact on a price. So we have dropped some of them. So now we have 5 columns, and then we'll see if our data is having any null values or not. So as you can see, there are one null value in location, some of in size, and 73 in batch. So compared to the data size of the data set, this is a very low null value. We can just simply drop it. We'll drop it and rename it as a new data set df3. We'll see the df3 shape. As you can see, not much effect, as even earlier it was 13,320. Now it is 13,346. Not much effect is done on our data. We have not lost much of our data. So we'll be keeping it. So now in the next section, what we are doing, we'll be doing feature engineering part. Okay, we'll be doing feature engineering part because we have not done any data analysis part, because there is not much to do. There is not much to do in this. So we will call it data pre-processing. So in the next section, what we will be doing, data pre-processing. So in this, we are adding some of the new features, or we'll be adding some new features for the bedroom hall kitchen. As you have said, if you'll see the size, it is given the size 2 BHK, 4 BHK, 3 BHK. So we don't want this string part. Okay? We don't want. It is pretty understandable. We will create a new feature which will say BHK. So if we'll add the number, it is pretty understandable. It is 2. That means it is a 2 BHK. This 3. That means it is a 3 BHK. So I am creating a new column, new feature DF3 BHK. Then I am saying okay size, and I'm saying apply. Lambda is basically a command in Python. For that, if you don't want to define a function another line, you can simply define a small function in the same line and execute it using lambda. I am saying int.x.split it with the space bar. The space is here, and give me the very first string. So it will fetch me the integer part. Okay, then I'll say bhk.unique. These are the different unique variables. There are around 18 till 18. Okay, 18 is a very big house, as you could have imagined. 18 BHK, so it is a very big house. So from 2 to 18 BHK. then what we'll be doing, we'll be converting our square foot to numerical variables. Now what I did, I defining a function convert square foot to numerical variables. Then I'll say token, I'll say okay, split it with the help of this help a split column. Okay, then I'll tell you how I'll apply it. Then I'm saying okay, if the length of token is equals to 2, then it will return it. Then I'm taking return it this return this value. Okay, return this value. Then and I'm saying if else, then return the normal float value. Then I'm saying okay, create a new column df4. I'm copying all my df3 values and applying this function. I am applying this function to my what value, total square foot value. If you'll see my feature, this is my total square foot value. I'm converting this into I'm converting this into int variable. Okay, so what I'm doing, I'm applying this function to this. What it will do, it will basically just convert this whole function into a proper int format. Okay, nothing it else is doing. So I'm saying okay, df4 and fetch me the, if there is any null values or not. I'm taking okay, no, I remove all the null values. Then I'm converting, or I'm taking all my data set. Okay, so now this is my data set. I'm taking only two values. My 5 columns are there, and I have my total converted my total square foot into a proper float value. Then I'll be adding a new feature. I'll be adding a new feature which is called price per square feet. What it will be giving me, it will give me the price per square feet. Okay, I have the total square feet. So now I want a price. What is the price of that location in per square feet? For that I'll be saying okay, I'll be making a new data frame. It is always better when you add a new feature, create a new data frame. Okay, so that if something goes wrong, you can work with the previous data frame. So I'm saying data for df5, create a new column price per square feet. I'm saying df dot price, multiply with it is by 1000 and divide it with the total square foot value. So it will give me the price per square foot value. Okay, it will give me the price per square foot value. As you can see, this is my price per square foot value. So now what I'll be so this is my complete data. Okay, this is my complete feature engine. I have removed some of the features and I have done all the different features which I have to add. Now in the next section we'll be doing some more data pre-processing techniques, in which we'll be doing the dimensionality reduction and removing outliers, all the different techniques in the next section. So let's get further. Welcome to the next section of this project. In this we'll be doing some data pre-processing techniques, that is using dimensionality reduction or removing outliers. So now in the previous section we did some feature engineering part, in which we removed some feature, added a new feature called price per square foot. So now in this section what we'll be doing, we'll be using the dimensionality reduction of location, because as you see that the location is having a large number of locations. So which if we'll do the one hot encoding, it will create a huge number of problems. If it will create a many number of dummies if there are large number of locations. So what we'll do, we'll just see that okay, how many locations are there. So as you can see, there are many number of locations, around 1287. 1287 is the length. Around there are different locations. So what we'll do, first time I'm applying a strip command. Basically what strip command does, it removes all the space, which is space variable or any character present between the end and last of a string. It is a simple function. Then I would say that as now there are many number of locations, right? So now if I'll see the sum values, there are around 13,200 total locations, in which many number are same, like Whitefield is 533, Sajapur Road is 392. So these are all the things. So now what I'll be doing, there are around the 240 locations which are having the location stats of greater than 10. That means that around more than 10 number of houses are present in that location, that there are at least 240 locations of that sort. So now that means around 1287 total of houses present. So now what I'll be doing, we'll be removing all those other locations in which in that location less than 10 houses are present. We'll be naming this an other, and we'll be keeping only those 10 main locations. So that this is the same thing which is written here, and in any location having less than 10 data points or houses will be tagged as other location. This way the number of categories can be reduced by huge amount. It will help us in having fewer dummy columns. So now what I created a new column, location state less than 10. Then I did location state, give me those variable which is having less than 10 location stats. Okay. I've created new data. I create a new data frame. Then I create. As you said that there are a total of 241 of that locations or total houses. Then this is the same thing which I've done. What I did, I created a lambda function in that said other if x in location state less than 10 x else. So this is a very simple code which I did. I explained you the logic. Now in the next thing, in the next thing, what we'll do, if I want to see, okay, again the unique thing, then I'll again see the same thing. Okay, I'll just execute this command once more. I'll just execute this command once more. Then you'll see that okay, all of these things are reduced to 241. Okay, locations are reduced to 241. Earlier there were around many number of locations. Okay, the location reduced to 241 again. So there were around 1000 locations. Right now it is reduced to only 241 locations. In the For which the last location is other, in which the total houses count is less than 10 in that location. So now the next thing what we have to remove outliers. So we'll use one simple logic which says that normally square foot bedroom is 300, that is the 2 BHK apartment is minimum 600 square foot. Okay. Example 400 square foot apartment with 2 BHK, then that seems suspicious and can be removed as an outlier. Obviously if we'll go with that logic, we can remove it. So what we'll do, we'll say in the DF5 if we'll remove it if the total square foot divided by total BHK is less than 300. We'll remove that. Okay, these are the different things. Also we will keep those only. Then we'll see the shape. We'll share the shape of our data set. Now 13,200 rows are left with the 7 columns. So now this is what we use. This is a very simple logic or the very simple domain logic for removing an outlier. So now what we'll be doing. Oh, okay, I have not done this. So now what we'll be doing, we'll just describe. Okay, price per square foot will be described. We are describing the new feature which we created. For that, the count, what is the count, what is the mean, maximum of that. So now what we'll be doing, we'll be using another logic to remove all the different outliers. For that, I'm defining a function. Then I'm saying okay, sorry, it is saying df6 is not defined. Okay, sorry, I mistakenly write it here df6. It is better if you don't write it on the form of numbers. Okay, as you say, it is very confusing. So now it is very, now what I did, it is a very another thing of removing outliers. In this the logic uses, here we find that the minimum price square foot is 267 rupees per square foot, where maximum is this shows a wide variation in property prices. We should remove outliers per location using mean and one standard deviation. So now what I am doing, I am defining a function. I am taking, okay, create a data frame called df out. Then I am saying for key sub df in df dot I'm grouping my df on the base of my location. I'm finding out my mean of that. I'm finding out my standard deviation for that. Then I'm saying I'm creating a new df, reduce df. I'm saying okay, fetch me only those location in which the price dot per square foot is greater than mean and standard deviation, and it is or also it is less than m plus st. That means the sum of the mean and standard deviation and the difference of mean and standard deviation. I am taking only those values in between them. Then I'm concatenating, I'm basically combining all my df. Then I'm taking, okay, return my df out, which is the new data frame which I have created. So now this is my data frame which I created. So this is my shape. Then I'm just seeing, okay, let's check if the given location, how does the 2 BHK and 3 BHK property looks like. So I'm just plotting a different scatter plot. So now in this also, okay, it is to be again termed as df6, sorry, df5, we'll turn it df6. It can be very confusing if you write it with name. As you can see, this is my various scatter plot which I created. In that I use the location for BHK2, in which I use the location DF location where the BHK is 2 and BHK is 3. I am just plotting a simple scatter plot with the help of this. So this is the Raja plot, scatter plot for Rajaji Nagar. As similarly, I can plot it for different other locations. That's why I created a function for it. So now in the next, I can also create the same for my another location, that is the Hippal location, and all the other things. I can use the same. Okay. So now this was the part one section. Now in the next part, in the next video, we'll be also using removing some outliers for the bathroom feature. Then we'll be using the doing the one hot encoding for the other things in the next section. Hello all, welcome to our second part of the data pre-processing part. So now in this section we'll be continuing with our outlier analysis and the different one hot. We'll be doing the different one hot encoding also. So this is a basic function in which I plotted a histogram between the price per square foot and the count to see that okay which price per square foot is in abundance. I used a simple matplotlib for it. I provide the data. So this is the count. As you can see, around 5,000 price per square foot is the abundance, and the least is around 15,000 price per square foot. As you see, as you know that there will be many low locations which are having an exotic location. Okay, in that location only the price will be high. So now the last thing we have to remove is we have to remove outlier using bathroom feature. For that I'll be using different variables or different things. So now for that let me So now what we'll do, we'll be seeing okay what is the unique feature, what are the different bathrooms available. As you can see, there are different bathrooms, 3, 2, 4, 5. As you can see, how this is the number of bathrooms which are available. So I'll just plot a histogram between this. So as you can see, number of bathrooms. So this is very unusual. Maximum number of houses having 2 or 4 bathrooms, right? And it is very unusual for a house to have around 6 to 8 bathrooms. So these are definitely are outliers. Okay, these are definitely outliers. So we can remove this. I am saying okay, df dot bath. Okay, these are the different outliers which are having the bath greater than 10. Okay, it is very unusual to have two more bathrooms than the number of two more bathrooms than number of bedrooms in a home. So I am saying okay, give me those data frame which is having the bathroom greater than the bedroom. Okay, it is obviously great. If a house is having 3 bedrooms, like it will have only around 4 bathrooms, not greater than that. But all the other cases which are having greater than that, that is basically an outlier. So I am just getting those values, then I am converting it to a data frame. Okay, this is my shape of the data frame. That is, these are the number of I am taking only those columns which are having the bathroom which is less than the total bedroom number. Okay, that means if a house is having 3 bedroom, the bathroom are either 7, either 3, or less than 3, or either. Okay, that I am taking only those data set. Then I am dropping my size and price per square foot because they are no longer required. I have already done all my feature engineering techniques. So now what I'll be doing, I'll be using the one hot encoding for location. As you see that there are many different number of locations. So as I've already done the dimensionality reduction, and we have already closed out to the maximum locations to other. So we are so this is the all the different one hot encoding for the different locations which we have mapped. Then I'll concat it with my total data set. So now as you can see my location, I'll just simply drop this location now because I don't need it. I'll just simply drop this location. Now if I'll see my final data set, so this is my final data set in which I have total square foot, total number of bathroom, price, BHK, all the total one hot encoding variables. Okay, so this is all the things. So now price is my independent variable. So this was all the data pre-processing and feature engineering techniques we did. I know it is a little bit of complex area because I have done a lot of research on how this price depends. You can have a look at the code and again if you look at it again 1 or 2 times, you will understand what I have done and what is the logic around it. So now my data is ready, my data to feed the model. In the next part, what I have to do, I just have to build that model. So very first for that I'll just split my data into dependent and independent variable. For that I'll use the X column in which I'll drop the price column, and Y I'll take only the price column. Then I'll take the train test split function. I'll split my data into train and test with a 80-20 percentage, 80 for price train data at 20 for test data. So now this is my total data ready for my model building. Now in the next section I'll be showing you how we can build a model using machine learning techniques. Then in the next section we'll be using the automated machine learning for the same. Welcome to the model building section of our project. In this section we'll be using the linear regression model to build our model. I have already splitted my data into dependent and independent variable, then train and test data. So now we are using the linear regression model. I am saying okay, from sklearn.linear regression import this. I am just fitting it, defining my model. I am simply fitting it. So now I'm just getting my score as 95%. So now this is a very simple step of fitting my model. But what I am doing now, I just hypertune my model to measure the accuracy of a linear regression model. For that, I'll be using k-fold cross validation. In that, what k-fold cross validation does, it basically splits my data into different folds and then feed my data for it. I am just importing from model selection shuffle swift and crosswell. I am saying okay, shuffle swift, it will split my data. Okay, I am taking number of split is equal to 5. I am taking my test size is 0.2 and random shift is 0. I'll just find the cross validation score for different splits. For the first split, this is my cross validation score, the second for this, and third for this, and all of the things. Now the result is we can see that in 5 iteration we get a score above 75% all the time. This is pretty good, but we want to test few other algorithms for regression to see if we want to get a better even score. So in order to obtain a better score, we'll just use a grid search CV modulation in a different. We'll be using different models. We have seen that the regression model is giving us around 95% score. Okay, so now what I'll be doing, I'll be using my grid search CV. Then I'll be importing lasso and decision tree for it. Okay, so grid search CV, I hope you all know what grid search CV is. Grid search CV basically test all the parameters and give me the best for that. So I am importing lasso regression, I am importing decision tree regression. Then I am defining a function find best model using grid search CV. So I am defining a function, I am passing my x and y. I am saying I have first defined my function for linear regression, for lasso and decision tree. So I have defined all the different parameters. In this I have given normalized function true false. For lasso regression I have given different alpha values and selection values. For decision tree I have given different criterion splitter values. This is a very simple code. It may look long but it's a very simple code. Then I have defined my shuffle slip basically to split my data out into different folds. I have taken number of splits 5. Then I am saying for algo any config in algo.items. Algo.item basically the different parameters. Okay, then I'm defining my grid search CV. I'm saying okay, this is my model, this is my parameters, fit it and append my. I'm saying that's okay. Append my different model names and the best score. Then I'm importing it into a data frame. Then I'm obtaining that okay, my linear model is having this best pair score. This is my best parameter. Lasso is having this, and decision tree is having this. So now based on the above, we see that linear regression give me the best score. Obviously, the linear regression is giving us the best score. So now this is what we did. If you want, we can predict. We can predict using the linear regression. So now I've already done that. We have defined a model as lr.clf. We'll just copy it. If you want to predict the results, we'll say that okay, lrcf dot predict. I'll pass my x test data. Okay, this is my data. I'll store it into a prediction variable, or if you don't want, you can simply compare it. If you want to compare it, I'll store it into pred. Then I'll say I'll use a different function and I'll say okay, sns dot bar plot. Then I'll say y pred. Okay, y test minus pred. Okay, sorry, not bar plot. I have not also. I have to just spell it. I just import SNS because I have not import SNS before. I'll import cborn as SNS, and I'll say I have to use distribution plot. Sorry, I'll use a distribution plot. Then I'll say okay, what is my distribution? As you can see, this is my distribution. That means my linear model is performed very well because my difference between the y test and y prediction is almost to near 0. Around 140 is near to almost 0. So as I already said, the 95% was my accuracy and my distribution also good. So now this is how you can predict your model or you can build your model. So this was all about the machine learning, model building, and data analysis and data pre-processing technique. If you will have a look at the code one or two times, you will understand what I have done and how I have done the things. So now in the final section, as you can see what I have done, all that I have written so much amount of code. I've used grid search, even all the other things. Now in the next section we'll be seeing how AutoScaling does all of this. Okay, this is a very low amount of code, and we'll see that how AutoScaling does all of this with a single amount of code. How it will hyper tune the model. It will give us the best model. We'll see all of this in the next and final section. Hello all, welcome to our final section of our project, that is the model building using auto machine learning library, that is the AutoScaling. So now I have already told you the introduction about AutoScaling, that AutoScaling frees a machine learning user from algorithm selection, hyperparameter tuning, the very thing which we did in the previous section using the lasso linear regression model, lasso regression, and the decision tree regressor. So now we'll be seeing how AutoScaling does this with no hustle and with few lines of code. So now the very first thing what you have to do is you have to first install AutoScaling. For installing AutoScaling, you can directly install it in your Google Colab environment or the Jupyter local environment. If you want to install it in your command prompt, you can install it there also by using such simple commands. But if you want to see for the documentation of how it is getting installed, you can just add an exclamation mark and install it in your notebook itself. You just have to install these libraries first in order to use the AutoScaling. So these are the different libraries. It will create an environment. Swigby will create an environment. Then it will install NumPy. Then it will AutoScaling. It is given requirement already satisfied because it is already installed. Okay, my AutoScaling is already installed in my function. So that is why it is saying requirement already satisfied. So now the next thing what we have to do is to restart runtime, because now the every time what you do, if you every time you install a library, you have to restart your runtime in order so that the library, so that the environment will read that library. So I have restarted my runtime. I'll import AutoScaling, then I import AutoScaling and I'll import the regression problem, because obviously this is a regression model. This is a regression problem. If it would have been a classification problem, I would have imported classification. So now if we'll use the same trained data, we'll use the same data which we have processed in for a previous model. So now if I have restarted the runtime, I have to again go and run all those cells in order to obtain my data. So I'll just simply run it. It will take only a few minutes. I'll just simply run it. This is the problem for runtime. Okay, so first in order, if you are using it, keep in mind that install these libraries first. If you will install it again, it will require you to restart your runtime, because it will, unless and until your restart is not your it is not restarted, your runtime is not restarted, your Google Colab will not read that library. So that is why the restart runtime is important. Now okay, now I have executed all of these commands again, and we have our extract and extest data. We'll simply pass that data into our AutoScaling library. So what I'll do, we have imported our AutoScaling. We'll see our data. This is my extract shape data. Then I'm defining my model. Okay, I'm defining my model. In that I am saying AutoML reg dot AutoScaling regressor. Then I am saying time left for this task. Okay, there are numerous amounts of variables or the different attributes which are present under the AutoScaling regressor, for which you can use. I have used time left for this task as 120, which means that it will run for around 120 seconds only. It will take only 120 seconds, and per runtime limit is 30. I have used this because of the time restriction, but there are many you can so what it will do, it will run for only 120 seconds, and it will give me all the different things which it has obtained in that sessions. So now there are different other variables. Now if you will go to your AutoScaling live website, now this is our AutoScaling website. So say this is the documentation. Okay, this is the classification part, but we are doing here regression, right? We are using a regression. So sorry, we'll do the regression part. AutoScaling regression. So this is their documentation. These are documentation. All the different things are present. Okay, how you can do there the, as you can see, it has also taken the perfect timeless for the task 120. All the different things are written: data loading, build and fit a regressor, view models found by auto scaling. So now what you can do after your model gets fitted, you can print the leaderboard. Okay, we'll do the same in this also. When our model gets fit, we'll print out the leaderboard. What it will do, it will print out all the, it will or basically print out the leaderboard or print out the models which perform the best based on the base of the cost function, or all the, it will also give me the duration also. Then what I can do, then I can show my, I can use a command show model. For that, what it will do, it will basically show the best performing model which is done as it has done here. Okay, then we finally see the score. What is the score? The same thing I have done it here also. So now as you can see, it is fitted my model. So now what I'll do, it exactly take 120 seconds to get my fitted model. Okay, as you said, the time left for the task is 120. Now if I'll see my leaderboard, I'll see which models perform best. As you can see, extra trees is the best performing model. Then I'll say show model. It will basically show all the details, what are the different pipelines used and what is the different attributes used. In this you can see, have a look if the different things are performed or not. Then I'll just predict my results. I'll store it into y prediction. Okay, these are my results. If I want to see what is my predictions, I'll use the same distribution plot. Okay, as you can see, my model is predicted very good because most of my density is around zero. My density, I have explained you how this distribution plot works. So my most of the accuracy around zero only. If I want to see in numbers also, I can see what is my MAE error, what is my MAE, RMSE and MSE. So this is my numeric accuracy, and this is my their total accuracy in the visualization form. So this was how you can use the AutoScalan library. With this data set, you can use different data sets also. I will be providing you the notebook and data set for the same. You can use this, and you can use this and build new projects. You can execute this command code line by line, and you can understand. We did 1 or 2 times. You will understand all the notebook in a better way. Or you can also use this and perform new projects for it, perform it on new data and create new projects on your own. So happy learning. Thank you.